Well, that was a hot mess. So I'm gonna sit here and eat some cereal. Oh wow, 14 of you now. Oh wow, hello, hello. Alright, I'm gonna wait like 3 minutes and eat my cereal. And then we'll get moving, I guess. So there is like a, I don't know, like a 2-ish, 3-ish. Oh, let's get a move on? Alright, fine. Let's do it. Alright, we're just gonna start from the beginning, I guess, of the review sheet. What cereal am I eating? I'm just eating like Honey Nut Cheerios out of a, oh crap, out of a Halloween bowl. Welcome to my life. Alright. So vectors and scalars. I don't know. What do you want to know about vectors and scalars? Are there any questions on it? Do you want to do a practice problem? Or do you want me to move on to what people told me they wanted help with, like motion, graphs, and what is that? Kinematic equations and such? I guess I'll just make up a practice problem since nobody's saying anything. This is so weird. Alright. Well, you're all gonna hate my handwriting on my computer, so I'm just gonna draw them out, hold them up, and then we'll do them. Well, I actually do have practice questions on a PowerPoint eventually when we get there. But anywho. Horizontal projectiles, sure. I'm gonna do motion graphs first, though. Alright, so let me find this. This is gonna look really weird for a moment. And then, you'll all just have to deal with it. I will fix it. Alright. Whew! Alright. Alright. I think that should do it now. Alright. Alright, so we're gonna do motion graphs first. So one of the first problems that we are... Can I just share the exam? No. That'd be a no. Jenna? I don't know where Jenna is. Anywho, you're all distracting me. I'm going to go over this example problem that's on the screen now. So, again, you can either be given distance versus time graphs, or we can be given speed or velocity versus time graphs, and we need to know what to do. So if we're given this graph here, I guess I could make it full screen, but I don't really feel like it. If we're asked like a question like number 1, what is the total distance traveled? So we pretty much just have to look at the graph, but we have to remember that the graph says your displacement versus time. So your total distance, we would figure out where the highest point is. So right here, 16 meters. And then technically, according to this graph, we move backwards in a straight line. But remember, your total distance, it doesn't matter which direction you're moving. We still have to add that on. So we go from 16 to 8. So, wow, my brain is fried. But that's what, an extra 8 meters. So then we would just do our full 16 plus this 8 down here. And your total distance would be 24 meters. Slow down. Oh my gosh, fine. I'm going to eat some cereal. Let me know when you're ready. I'm waiting on you to tell me you're ready. I'm legitimately just eating my bowl of cereal. We include this other part in the distance because remember, this graph is showing us the displacement. So our displacement, our distance, we want everything. We want everything included. It doesn't matter. So this just tells us we're like moving forward and then we're moving backwards. But again, if you were to like run a whole mile just running back and forth, you want to count everything. So you go up to the 16 and then we have to include this part as well for your total distance. If you are given, it doesn't matter, even with the distance versus time graph, same thing. Rate the difficulty of the exam? I don't know. That's a weird question. Alright. Moving on. Number 2. What is the velocity at t equals 2 seconds? So remember, this is in the review sheet. So your velocity when we're given a displacement versus time or a distance versus time graph is the slope of this line here. Wait, what? The total distance is 24 meters. Oh, fine. I'll do it so I can write on it. Hang on. Nope, not that. Alright, so what is the velocity at t equals 2 seconds? Yes, Lola, I am going to do all of these. Alright. So again, at t equals 2 seconds right here, we should know it's going to be the slope of this line. So the slope of this line, basically, again, the slope, your velocity is going to equal. Wow. So again, the slope is the same from t equals 4 seconds to t equals 0 seconds. So to make my math fabulous, I would just do my rise over my run. So you have your 8. Oh my gosh, this is so bad. Minus 0. And again, from that entire point is 4 seconds divided by 4. So your velocity would be 2 meters per second. This is so bad. Don't worry, kinematic equation ones I'm legit going to write out on a piece of paper. It's really not that confusing. I don't know what we're confused on. What are we confused on? Alright, so what you are all saying, here, I'll do that math. So if I wanted to do from 0 to 2 seconds, that would be 4 then, divided by 2. Which still gives me 2 seconds, 2 meters per second, because guess what? The slope of this line from 0 to 4 seconds is exactly the same. I didn't do the time wrong. I'm explaining that right now. Let me know if you still think I did it wrong. I know I just did from 0 to 4 seconds because that's the way my brain works. Because the slope of the line from 0 to 4 seconds is the same. I'm slurping my milk because you're all annoying me. Can I move on now? Oh no, my computer is frozen. SOS. Number 3, total displacement. This graph shows the displacement, so my total displacement is just where it ends, so I just read straight over, and it is 8. Questions on number 3. It's just 8 meters. I think this was the worst idea I've ever had. This shows displacement. This is my total time. I just go up, hit where the graph is, total displacement. Okay, now the more important graphs, your speed versus time graphs. You will have, I think 3 or 4 of these. So, how long am I doing this for? I don't know. Till people stop having questions. Alright, so on a speed versus time graph, the important thing that we need to know, so if we were asked a type of question, I'm sorry I didn't write it out, but for instance, what was the total distance traveled in those 5 seconds? So the total distance traveled in those 5 seconds would be the area underneath this graph. So again, total distance is going to be this entire lovely little triangle down here. So if you all forgot what the area of a triangle is, it's 1/2 base times height. Maybe write it on your half sheet of lavender paper. So looking at this graph, my base is 5 and my height is 25. And then I multiply that by 1/2 and you should get a total distance of 62.5 meters. And then, if you were ever asked anything about the acceleration, you would just take the slope of that line. Yes, Ellie, speed versus time and velocity versus time is essentially the same thing. Can I write it out? Fine. 1/2 base times height, which equals 1/2 times 5. Wow, this is so bad. Times 25. And then you do your math, and that is equal to 62.5. I'm not writing on my computer anymore. We're going to go back to my face. How do you find the R to figure out? I don't know what that says, Sydney. So that would be your total distance or displacement. Alright, I mean, that's pretty much all you're going to need to know for a speed versus time graph. How do you find the slope for acceleration? Yes, it's just rise over run. So, here, I'm going to actually write this out. We're going back to my face. Okay, so, for the slope of that graph, rise versus... Oh, I just hit Atlas in the head. For the slope of that, you would just do your rise over your run, like so. And looking back at the graph, we went from 0 to 5 seconds, so your top would be, your bottom. Your bottom would be 5 seconds, and then the top would be from 0 to 25. So we had 25 divided by 5. Which equals what? I don't even know. I can't do math right now. Was that even on the screen? I wasn't even looking at myself. Based off the graph. No, I'm not going to give you a scenario and you have to graph it out. You're just going to have graphs and you're going to have to, like, analyze them. Atlas just went away from me because I hit him in the head with the clipboard. Oh my god. Fine, he's coming back to me. I'll show you Atlas. How do you find the speed when the graph is all weird, like a rectangle and a triangle? I don't think you're going to have to do that. Oh, average speed. Oh, I know what you're talking about, Lola. Thanks, bud. You would have to... Yes, you would have to take the total distance divided by the total time. So whatever area is underneath, whether it's a triangle or a whatever, and then divide it by the total time. He's fine. Alright, so can I move on to kinematic equations? Can we possibly do one? Okay, Lola. Sounds good. We'll do one. Hang on. Go ahead. Alright. Here we go. So I believe this was the graph in the review packet. Atlas. Come on. Come on, Danielle. So what, like let's say we were asked for the average speed for all of 6 seconds. So again, your average speed is the total distance divided by the total time. So what we would need to do is to get our total distance is we would have to split this up into your rectangle and your triangle. So remember, like, your average speed would be your total distance divided by your total time. So I'm not going to write out that formula. So then what you need to do for total distance, again, for the triangle, oh, I think we're just asked to do total distance for this on the review packet. You get 1/2 times my base, which let's look at our time. My base is 4, times my height, which, again, my height, I go from 0 all the way up to 10. So this triangle would equal 20. But again, that is not my total distance. That is just the triangle. So now I have to do this little rectangle dude over here. So then that would equal my base times my height. So again, and then looking at this rectangle, my base is from 4 to 6, so that's 2, times my height, which is, again, 10. So then this part's 20, so I have a total distance of 20 plus 20, which is 40. And then again, they want your average speed, so your total distance divided by my total time. My total time is 6 seconds. I didn't bring my calculator, so hang on. Yeah, so you add up the area, and then it's over the entire time. So 40 divided by 6, oh, 6.66. We'll say 6.67. Okay, are we good with motion graphs, or do people still have questions? Can I move on to kinematic equations? Yes, is everybody okay with that? Yes. Okay. Kinematic equations. I have a lot of examples. So, I'm going to put an example problem up, and then I think Atlas has to go out. So you all try to do it, and in about like 2 minutes, I'll be back, and we will go over it. Hope that works for you. There's a question like this on the final, not the final, the midterm kind of. So let's see if you could do it. Good luck. I'll be back in like 2 minutes. Oh, confusion, I see. Can everybody at least write down the problem? Because I am going to, like, handwrite this with my face. So can everybody make sure they have the information in the problem, and then I'm going to switch to my face. I'm not going to say the answer yet. I don't know if Atlas has to go out. He's just been running around, ignoring me. Yes, you split it into horizontal and vertical. Basically, the bomb's being dropped, if that helps you. It's just being dropped. So your initial velocity in the vertical direction is 0. You don't always have to split it up into horizontal and vertical. It depends what type of problem it is. So if it's just a free fall problem, you're only in one direction. But this, I guess if it'll help you, is more of a horizontal projectile. Yes, for part 2, you find the initial velocity in the horizontal. If we dropped it, well, I guess we're not dropping it. I guess we're sliding it like, I'm sorry, I shouldn't have said that. I guess it's like we're sliding a book off of a table, except we're sliding a bomb out of a plane. So we have a horizontal velocity, which we don't know yet. That's what we're trying to solve in part 2. And then the initial velocity in the vertical direction is 0. It depends on the problem whether you have to split it up. I don't know what to tell you. Okay, does everybody have the problem at least written down? Can I take it off of the screen? Because I'm going to. Okay. Alright. So here's my lovely little diagram for you all. This is what we know based off the problem. So ignore me trying to look at this. So we know that the horizontal distance is 4,000, that my vertical distance was 20,000. So in the horizontal direction, we don't know the velocity. Eventually, we're going to have to solve for it. And we know my acceleration in the horizontal direction is 0. So knowing that it's being just kind of pushed off, my initial vertical velocity is 0. My acceleration in the vertical direction is always 9.8. So my distance, again in the vertical direction, right in the problem, is 20,000. So what you need to do, I mean the first part of the problem pretty much tells you this, is how long was the bomb in the air. So we have our 3 variables in the vertical direction. So we would use the equation distance equals VIT plus 1/2 AT squared. And you solve for the time. Eventually, I'm going to go through and do the work. No, the 4,000 is in the horizontal. Right now, we are in the vertical. Acceleration in the horizontal is always 0, yes. So then, plugging everything in, we get distance. So your 20,000 meters is equal to 1/2 9.8 t squared. And then you get like 4. So then you get like that number is equal to t squared. So then we square root them. And we get t should be equal to 63.89 seconds. So that was the total time in the air. Questions on that part? No. Can I move on to part 2 of the question? Yes, it's 63.89 or 84. It's the same. It's not really that difficult of a question. No, they're not this hard, to be honest with you. Okay, so then part 2 of the problem. Again, time is the one variable we can move over, so I'm going to move it over to my horizontal and put it in there. So I moved it over. So time, I could take it and move it over here. So now, I also, sorry, I don't know why I didn't write this in the beginning. I also know my distance is what, 4,000 meters? Did I put 4,000? I think it was 4,000. So now I have 3 variables in the horizontal, and I can solve for the speed. So again, we're going to use the same equation. Where am I going to fit this in? I'll fit it in down here. So your distance is going to be your velocity times your time. So you get 4,000 is equal to your velocity times 63.89. Do your math. And you get your velocity is equal to 62.6 meters per second. So I did my work down here. Your distance is equal to your velocity squared, because remember my acceleration is 0, so the second part of that equation is going to be nothing. And then you solve for it and you get initial velocity of 62.6 meters. You did have to square the time, so that's why I square rooted the answer. Questions on part 2. Yes, no, maybe so. Amanda, doesn't matter. Legitimately doesn't matter. Use 9.8, use 9.81, it does not matter. It will not change whether you get the answer correct or not. Nope, next. Alright, do you want to keep doing the same thing? I give you an example problem and then go over it, or no? Okay, so I'll give you another example problem. Make sure to write it down, because then again I'm going to show all my work like this, and then we will go that way. So the next example problem, boom. Hopefully we should all be able to do this one. If not, oh well. Alright, so take a few minutes, get that done, and then we'll move on. Lauren, I have never taken off a point for somebody using 9.81 and 9.8 because they get an answer of 63.83 and I got an answer of 63.89. I have never taken off a point. So it doesn't matter. This is considered an angle projectile. Notice how it has 30 degrees in there. Fan beef. Oh, crap. Yes, that means you have to use cosine and sine. The sine and cosine is for finding the initial velocity in the horizontal and the vertical directions. You use cosine for horizontal and sine for vertical. Yes, that is correct. Is your answer 12.5 seconds, Ariel? If so, that's wrong. For horizontal, are VI and VF the same number? Yes. Yes, the answer to sine and cosine is basically the horizontal velocity and the vertical velocity. So you have to solve for your time. You want to make sure you're answering what they're asking for. So how long is the ball in the air? So we should be solving for time. I mean, 21.6 and 12.5 are velocities. Yes, Emily, that's what you have to do. Yes, it matters if you use sine or cosine. You have to use the right one. Did you use a negative acceleration? Your initial direction is up. So the acceleration is down, so the acceleration is negative. Wow. No, you're in degree mode. Okay, hopefully you have this all written down. I'm going to go over it. This is the information we were given in the problem. So we can figure out the initial velocities in both directions, because that's when you use sine and cosine. Then we know acceleration in both directions because we wrote it in the review packet. Make a note to yourself, if your initial direction is up, your acceleration is going to be negative because they're opposites. If the initial direction is down, then your acceleration is going to be positive. That's how you know when to make it negative or when to make it positive. So looking at both the vertical and the horizontal, we only have two variables. So how can we solve for time? So this is when you have to remember you can cut a problem in half and make a variable 0. So that's when we make our final velocity in the vertical direction 0. Because remember, at the highest point, the ball stops for a split second, so therefore the velocity is 0, the final velocity in this case. So then we would solve for time. So we're going to use the same equation. We're going to use distance equals VIT plus 1/2 AT squared. Then, if you... Oh no, I totally lied. You are not using that formula. I'm sorry, I was looking at the wrong problem because we don't have a distance. You're using VF equals VI plus AT, and you are just going to solve. So your VF is 0. Your VI is 12.5 plus negative 2. So that is what you should get. Yeah, there's another live stream at 2, but it's probably just going to go into this one. $12.5 is wrong because that's not the time. So then when you solve for the time, you should get a time of 1.27 seconds. But then we are not done because that is only the time halfway. We want to know the total air time. So you would multiply this by 2. So you multiply that by 2 and you get a total air time of 2.55 seconds. So that's part 1. You split it up because it's a projectile, so we can't talk about physics at an angle. We can only talk about physics in a horizontal direction or a vertical direction. So we have to split it up and figure out different parts. What don't you get? You split it up and make VF 0 when you need another variable. You don't square 1.27, you multiply it by 2. Okay, let me do one question at a time here. This is getting... Okay, so we make VF 0 if we have a horizontal projectile, or not a horizontal projectile, a vertical projectile, and we only have 2 variables, and we need our third variable. So we have to just remember that the time halfway is the same as the time down. So I could split it up because I know that whatever object it is going to stop for a split second, so I can make my VF 0. But then I just have to remember that that's only half of the time, so I have to multiply by time by 2 to get a total time of 2.55 seconds. Why isn't 25 VI in the horizontal? VI is not 25 in the horizontal because it says it right in the problem that we were launched at 25 meters per second basically at an angle. So that's your angle. We're not told up and we're not told horizontally. We're told we're launched that way. So that's when we do our little angles. Any other questions on the first part of this problem? Or can I move on to figuring out the horizontal distance? Okay, I'm moving on. So for my horizontal distance, now again, I technically only have my 2 variables in my horizontal, but I just solved for time down there. And time is the one variable that I can move over. So now I move time over to my horizontal. Time is equal to 2.55 seconds. I have my 3 variables in the horizontal. I can go and solve for my distance. So you use just distance is equal to VIT plus 1/2 AT squared. Again, the 1/2 AT squared is going to go to 0, so I just ignore that part. So I get distance is equal to 21.65 times 2.55. And then if I solve for that, I get a distance of 55.2 meters. Questions on that part? I feel like once we get the time, I feel like this part is what everybody's confused on. But then once we get the time and we can move it over, everybody understands how to do that part. Why does what become 0? The acceleration? The A2 squared becomes 0 because you're multiplying it by 0. Your acceleration is 0. 55.08 is okay, yes. I feel like a lot of you are overcomplicating things right now. But anywho. Questions? I'm guessing we want to do another example problem since we're all confused with this. Yes, I'm waiting. The acceleration is negative 9.8 in the vertical direction. You have to remember we have to split it up. We have to split it up. In the horizontal, my acceleration is always 0. My vertical, it's 9.8, but then I have to figure out if it's negative 9.8 or positive 9.8. I'm going to do another example problem. Let's see what I got. Hang on. So it wouldn't matter if I got 55 points or 8. No, that wouldn't matter, Cassidy. Alrighty. New example problem. Oh, sorry, that's supposed to say 25. Here you go. Good luck. Can you see the problem? Oh yeah, never mind, it's there. This one you don't have to split up. You're only going to have to split it up if you're given an angle. Or it's a horizontal projectile, which on the midterm it is you're told it's it's pushed horizontally, or something to that effect. It's just thrown straight upwards. It's like a free fall problem. So your initial velocity is going to be 0. Not 0, sorry. Your initial velocity is going to be 25. Again, make sure you write this down if you want to follow along. And, I mean, this is yes, so this is just vertical. It's just a free fall. Because on the midterm, you're either going to be given an angle, and that's how you'll know it's an angled projectile, or you will be told that it's, like, pushed horizontally off of something. Your initial direction's up, so that should tell you what the sign on your acceleration should be. I'll give you a hint. You're going to have to solve for time first. And then you can figure out the speed before it hits the ground. It's kind of similar to the one on the review sheet. You only have 2 variables, though, but that's when we say something is 0. What did we do in the last problem to figure out the time? So you're going to have to figure out time first. I'll at least give you that. And then see if you can figure out what to do with time to figure out the speed right before it hits the ground. You can assume VF is 0 at its max height when you throw something in the air or something is launched in the air. Now I'm going to slurp on purpose. VI is going to be 0 in the second part of this problem. I just answered when BI is 0. BI is going to be 0 in the second part of the problem. Wow. We really should have paid more attention in class when I was going over this. I bet you all thought you would get it in the live stream. Oh well. Alright, hopefully you have this written down. I'm going to start going over it. First part, so we throw something straight up. Nope, it's a two-part problem because that's the only way we're going to find our final velocity. Well, actually, I lied. You could have just, it's still a two-part problem. But anyway. I didn't say, well, it's a one-dimensional problem. Alright. So this is what we can assume. My initial velocity is 25, my acceleration is negative, because again, the initial direction's up, so gravity is always pulling down. And then my final velocity is 0. So if I then go and solve for time, so I use the same equation that I did in the last problem, which is VF equals VI plus AT. So then I go through, plug everything in, which I'll do for you all. 25 minus 9.82. And then you solve for T. Your time equals, to your max height, your time is going to equal 2.55 seconds. I got 25 too. So then, now you're here. My time equals 25.55 seconds. Now you have to think about this. So if I then split it up, from the max height down to the ground is another 2.55 seconds. So I want my final velocity right before it hits the ground. So this is when I'm going to switch some things around. Show me how I did time again, like that. So you get negative 25 divided by negative 9.8, and that should be 9.55. 9.2.55. So now, because when something is going up and then coming back down, we cannot just double the time. Say my initial velocity is 2.5 meters per second, and then kind of use negative 9.8 the entire time. It's just not going to work. So for part 2 of this, here I'll write part 2. Our initial velocity is now going to be 0 because now I'm at the max height. So I'm at the max height. And now I'm just talking about the way down, so right before the ball hits the ground. My acceleration is now going to be positive 9.8 because I'm on the way down. And we know the time is 2.55 seconds for that half. So that's what I now know in part 2. Wow, you're all probably crying because you think you're going to fail the midterm. It will all be okay. So now you can solve for your final velocity. We use that same equation. So roughly 25 meters per second yet again. Questions? Comments? Concerns? Yes, for speed and velocity at a split second are the same thing. There is only one V in the horizontal, but we're not talking about horizontal. We're talking about throwing something straight up. When is speed acceleration? Speed is never acceleration. Acceleration is your change in velocity divided by your time. I would say the questions on the midterm. Some of these questions are like the questions on the review packet. So, like, especially the one at the angled projectile one that we just did. There was one on the review sheet exactly like this. So I would say they're like the ones on the review sheet. Do we have to know the coefficients of friction? No, you'll be given them if you need them. Okay, next question. I'm guessing we want to stick with kinematic equations. Have fun. Yes, we'll do more than one, then move on so people can leave this live stream. And then if you people really want me to go back, I guess I'll stay till forever and do this. Throwing something off something? Throwing something off something would just be a horizontal projectile. This is very similar to the last question we did, so think about what we did. You won't have a question like that? You're throwing something straight up, so VI is not 0. You're... To figure out how high the ball traveled, yes, VF is 0. Acceleration is negative, yes. Acceleration is negative, yes. You don't have to solve for VI, so I don't know why we're solving for VI. Oh yes, we do have to solve for VI. Sorry. No, you don't have to do the second part first. Alright, I'm going to start going over it, and then we're going to move on to force, and then we're going to call it a day. Alright, so... this is what we do for the first part. We're throwing something straight up. We are given that the time is 4 seconds. We're throwing something up. Gravity's always pulling me down, so my acceleration's negative 9.8. And then we have to assume, because we want the distance it goes in the air, so we're at the max height. So at my max height, we know that my final velocity is 0. No, you should never get a negative distance. So then over here, I have to use VI, because I have to solve for VI, because every single equation has a VI in it. So when I do that, again, I just plug in my numbers. I have 0 equals whatever times negative 9.8t. And then you get that your velocity is 39, your initial velocity is 39.2. So now that you know that, I use this equation. You could also use VF squared equals VI squared plus 2AD. But I didn't do the second part first, Lola. This is the initial velocity. Doesn't the question ask you for your speed when it returns to the ground? And then, so you just plug everything in, you solve for your distance, and you get 78.4 meters. So that's how high the ball went to its max height. Questions on this part? Or we're going to move on to part 2. Alright, so for part 2, I'm asked the speed before it hits the ground. I mean, they may end up being the same, but I didn't do the right math for it. So this is when I'm at the max height, so then I consider my initial velocity 0, my acceleration is 9.8, and we're given my time is 4, so then I want to solve for VF. So that's what I have, and that's what I want to solve for. So I just use VF equals VI plus AT. So then you get 9.8 times 4, so you get your final velocity is 39.2 as well. Questions? I'm going to move on to force. If you have issues with kinematic equations, VI is 0 because we're assuming it's at the max height and we're just doing the half down. So then it took me 4 seconds to get to my max height. It'll take me 4 seconds to get back down. Do you not take the negative of 39? I don't know what you're talking about. I don't know where Atlas went either. Alright. If you want more practice with kinematic equations, remember this book? Let me look. Page 34 through 49 should give you some example problems. So in this book, page 34 to 49 goes through some kinematic equations. The distance was... Lauren, just always use a full equation, and then your zeros will cancel out the other half of the equation, and that's how you'll know. The distance was 78.4 meters. Alright, on to force. So if you need a coefficient of friction, you'll be given it. You need to know the formula for the force of friction is the coefficient of friction times the normal force. You need to know what the normal force is, and you need to know how to figure out net force. So I think I grabbed some pretty simple force problems, but I thought the same for kinematic equations. So I just want to get through the force problems, then if anybody has any major questions, I'll answer them. If not, you can leave, and then I really don't want to start another live stream at 2, but I probably will. Anyway, alright, here we go. Copy down the problem, figure it out, and then I will go over it. Oh, sugar. Oh, there it is. Yeah, probably in one question, Lola, we will, but you probably just confused a lot of people. Remember, force is always in newtons, accelerations meters per second squared, and mass always in kilograms. So is everybody done with this problem? Because this was a really simple problem. Hopefully you have it all written down. Here we go. Sorry, I keep moving. Whew. Simple as that. Simple as that. We know that my net force, if I know my net force, it's simply just equal to the mass of the block times the acceleration of the block in this horizontal, sorry Julie, I saw that too late, in the horizontal direction. So we were given the net force, and I was given the mass of the block, therefore I can figure out if my block is moving in the horizontal direction. So I just plug everything in, and I solve for it. The one thing a lot of people were getting confused on the test is I also told you all that the net force is equal to the force of friction, I lied, force applied minus your force of friction. The one at the top. That is true. We only use this, force net equals my force applied minus my force of friction, if for some reason I'm given my net force and I need to figure out my force of friction, or if I'm given my force applied and my force of friction, I have to figure out my net force. I mean, they're both the same thing. So anyway, questions on that one or another example on force? Wow, everyone's pretty quiet right now. Okay, another force problem. Here we go. Everything we covered today on the review packet and on your tests will be on the midterm. When do we use an acceleration of 9.8? Only if something is in the vertical direction. With our forces, we were never going to use an acceleration of 9.8 because we're always going to be pushing something horizontally. It's never really going to be falling in the vertical direction. If it is falling in the vertical direction, we're back to kinematic equations. We're not using anything with force. We would use 9.8 if we were trying to figure out the normal force or the weight. We would never use it for the force of friction. We would only use 9.8 for the normal force and the weight, because weight is the force of gravity on you. I believe this was a test question, this one. So your 30 newtons is your force applied. That is not your net force, if that helps. But you are given your mass and your acceleration, so you can figure out your net force. And then you could figure out your force of friction. Okay, do we all have it written down? Can I start going over it? Okay, I'm going to. Alright, so as I was explaining when some people were writing down the problem, we know that my net force is my mass times acceleration. In the problem, we are not given your net force, we are given my force applied. So to figure out my net force, you just do your mass times your acceleration to get 20. And then again, we know that my net force is my force applied minus whatever my frictional force is. So then if I solve, we should get a frictional force of 10 newtons. Questions on that? No? Okay. Fabulous. Alright, one more example problem, I guess. Let's do it. Does everybody have it written down? Hope so. So this is where you just need to remember that your weight is your mass times your acceleration. If we're on Earth, we know the acceleration is 9.8, but we're not. We're on a different planet. So then you plug and you figure it out, 39.2 kilograms. The only problem that I didn't get, because I had to fix the live stream issues, was something using the force of friction and figuring it out with the coefficient and the normal force, but you have so many example problems on tests and review sheets with that, so I don't really feel like doing them. Other than that, what are questions we have besides kinematic equations? But I guess since I'm kind of done, why kilograms, not grams? Because you have to remember a newton is a kilogram times a meter over second squared, so we have to use kilograms. Always kilograms for force. Can you do a question finding average speed? Sure. Here, I'll give you the first question-ish kind of on your midterm. So we need to remember that speed is your distance divided by your time. I mean, you're not... You basically just have to use a kinematic equation for all that nonsense. Let me see. I have to type it out, sorry. I mean, you may have a simple question like this, which I think this is pretty simple. So remember, speed is your distance divided by your time. So if you're given a question, ooh, the average speed of a plane is 500 meters per second. Sorry, that's supposed to say travel, not ravel. How long would it take to travel 100 meters? So again, your speed is your distance divided by your time, so you just have to solve for it. So I'm pretty sure we should all have this written down right now, so I am about to help you all solve this. In terms of the other questions, you just have to know how to use a kinematic equation. But so in a question like that, it's really simple. Speed equals distance over time. You know your speed is 500, my distance is 100. You just solve for time, and it would be 0.2 seconds. I mean, there are simple questions like that. There are simple questions just using cosine and sine. There are simple questions using motion graphs. There are, here, I'll look at the midterm. Does the acceleration due to gravity ever change? No, so please remember that. Acceleration due to gravity never changes, no matter if you, like, if I increase my weight by, if I double my weight, the acceleration due to gravity on me is still the same. I think they're all pretty simple. I mean, I didn't go over every single type of problem you're going to see on the midterm because it's already been, what? It's already been so long. It's already been an hour and 20 minutes. And we've gone over like maybe 5 practice problems. So, yeah. Any other questions? I mean, I gave a lot of hints when I was going over the review sheet. Look over your old tests. The review packet is mostly what the midterm is. I think if you know the review packet, you'll at least like get an 80-something on the midterm. But if you're going for the 90-something, I would suggest looking over your old tests. When do you use the formula? Oh. Okay, that formula. Let me write that out. You all need to actually put this on your lavender sheet or you're going to get one question wrong. So your force of your gravitational pull is equal to your big G times mass 1 times mass 2 all over your radius squared. You need to know that big G is 6.67 times 10 to the negative 11. That needs to be somewhere on your lavender sheet or you are going to get a question wrong. Here, I'll find the question right now and tell you when you're going to need to know it. There's Atlas. You're told that 2 spheres are separated by a certain distance. And what is the gravitational force? So when you see the words gravitational force, use that bad boy. I don't get force of 1 equals force of 2 for these problems. You just have to know that when something's orbiting something, it's pulling it in at 600 newtons, and the other object's pulling it in at 600 newtons as well. They're the same. Equal. Equal but opposite. I don't know. So the radius is the same. I mean, whatever distance apart you're given, so like if I was told these 2 objects are 500 meters apart, if you look at the diagram I drew, that is my radius, because remember, it's orbiting like around it. I can't do it on here. It's orbiting around it. So it makes a circle. So whatever distance apart you're given, that's already the radius. If you have no more questions, you could stop watching me, but I will sit here if you have more questions. Are people actually going to watch this? And what is the small g in the equation? This one, Lola? Is this the one you're talking about? That? Where's there a small g? When you give us one with that equation, we'll be given the mass. Yes, you'll be given the mass, and yes, your whatever distance apart they are is going to be the radius. What g? I don't get what g you're talking about, Lola. Yeah, it's the gravitational pull. The radius is the distance. Yes, in these types of problems, yes. Yes, 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 yes. There are ones where we have to convert. No, there's no converting. How many tests have we had? 3? 1 first quarter, 2 this quarter, so 3. And like 2 quizzes. 2 quizzes this quarter? I wonder, were most of you people the people that wanted me to go live at 2? Circular motion, sure, Cassidy. Circular motion. So you have to know all those equations. The quiz is very good to look over. I think most of the problems are very much like the quiz. So the important things to know about circular motion. So if we have an object, and let's say this is moving clockwise, you would need to know how to draw in these vectors, and you would have to know what they mean. So remember, your force and your acceleration, because they're centripetal, are always these ones. They're always towards the center. So if you're given a diagram like this, and you're asked to draw in the force or the acceleration acting on the object, we would just draw it straight towards the center. If you were asked to then draw in the velocity vector, this is when we have to know that it makes a right angle with this force and acceleration. So this one down here would be my velocity vector. So that is the one piece of information you're just going to need to know, or you can draw this on your lavender sheet. And then all of those formulas. So like your centripetal acceleration is equal to, your centripetal force is equal to, using like 2 pi r. You have to know what your period is. But as long as you did okay on the quiz, which I feel like most people did, just reviewing those types of questions, I think those are the types of questions that show up on the midterm. G is 6.67 times 10 to the negative 11. Yes, Lola. Yes. Any other concerns? Because I should probably make sure Atlas is still alive, because I don't know where he went. And he's mad at me that I'm not giving him attention. Are the bonuses hard? I'll just say the first bonus you may have seen before. The second bonus no one's going to get, and the third bonus only probably a few people. What, Lola? I answered your question. Oh, when do you use it? The only time you would use it, it's just one question. The only time you would use it is when you have to use that formula. Can you see Atlas? Sure, I'll go get him. Let me know if you have any questions as I go get him. Any other questions? You need to know both, your favorite and your least favorite. He is. He's much bigger now, Taylor. He'll be there on Wednesday if anybody wants to stop on in. One of the bonuses is what's my favorite quote. Good luck. You okay? How are you supposed to know my favorite quote? I know. It used to be on the wall in my classroom at Niagara Catholic. If that helps. That's all I'm giving you. You're gonna have to stalk my Niagara Catholic life. You look so sad. It's okay. No one's here. But okay. Bye. He thinks there's an intruder. Any other questions? I'm just going to pretend like all of you were the people who wanted me to do the live stream at 2 and not do another live stream. Or is that bad of me? Are there people who just joined? Or no? The roommate's not home. I told you, she's never home. She was going to stop by, but she's not doing that till later now. She's not here. Yeah, I just joined, but I'll rewatch it. Well, are there any specific questions you have, Anna? Because I could just go over. I guess I'll just stay on this same live stream and make it extremely long. Tips for tomorrow. Remain calm. It's all gonna be okay. That's all I got. There's an angled projectile problem. Why are 13 of you still watching me? No, you're not going to be given the reference table. That's why you have that half. Oh, Taylor. See me in the morning. You have a half lavender sheet that you can write whatever you want on, front and back. So make sure you see me. I'm not going to be at school till like 7:30 tomorrow, though. So I have to drop this little one off at daycare. No, my quote is not to remain calm. Why did 2 more people just join? Are you my 2 o'clock people? I have a feeling I'm going to be doing this all over again. I know, little man, I am. No, you do not need your reference tables. That's why you have your half lavender sheet. Any formulas you need to be on that sheet. You are not going to be given them. You need that half sheet of lavender paper with all of your formulas on it that you would use in a reference table. Any other questions? Can I write down all the formulas you need to know? Sure, I'll do that right now. Hang on. You're being such a good boy. Yeah. I mean, that's a start. So speed equals distance divided by time. Your acceleration is equal to your change in velocity over time. Your three kinematic equations. Force equals mass times acceleration. I'm going to leave this up. And then you just also need the centripetal acceleration formulas, which I'll write down in a moment, because I'll give you a second to copy this down. Or I could take a picture after and just send it to you. Your period is equal to time. Centripetal acceleration, velocity squared, right? My centripetal force is equal to my mass times acceleration. I believe those are all of them. Take a picture. Any other questions? For the 9 of you still watching? Do like people think I'm gonna break out in like song and dance or something? Any other questions? Do you want to go over more example problems since 8 of you are still sitting there watching me? Example problems, Anna? Okay. I'm going to put an example problem up, and then I have to run and get something. And then, so make sure you have it written down. Maybe try to start it. And then I will be back. Okay? Does that sound like a plan? Okay, beautiful. If you were watching before, this is a different problem, so you can also try it. I'll be right back. Lola, you can do the lavender sheet in whatever as long as it's handwritten. So you could do pen or pencil. You are, I think there's, Cassidy, I think there's 1 or 2 questions about the coefficient. But if you need to use the formula, force equals friction times the coefficient times the normal force, I will give you the coefficient. So you don't need to write down those coefficients. All right, Anna, I'm just going to figure this out too, and then we can go over it. So hopefully you knew that well, there's more than Anna just watching, but she's the only one that will respond to me, so I'm going to pretend like you're the only one watching. So again, we have to split this one up into my horizontal and vertical. My initial velocities, we do sine and cosine. 40 sine times. Alright, hopefully I have this written down. I'm going to go over it with you. Hopefully you're still watching. Not, this is pretty sad. Alright, so for those of you that were here earlier and have been watching for like an hour and 45 minutes now, we have another angled projectile problem. So, what we know, again, when we're given the angled projectiles, how we figure out my initial velocity in the horizontal and vertical, so how I got the 22.98 and the 19.3 is by using cosine and sine. So hopefully you at least got that. Then in each direction I know the acceleration because we went over it. It's something you need to know. Remember my initial direction's up, which is why my acceleration in the vertical is negative 9.8 because they're opposites. So in the first part of the problem, it asks me how long is, I guess, this ball that we, oh, I'm supposed to say a person, that didn't match at all, is launched. So then what we have to do is, the only way we're going to get my third variable, as I kind of started writing it, is we have to assume that my final velocity is 0. And then we can use the equation VF equals VI plus AT, that equation. So I'm going to go and solve for my time really quickly. So you have 19.3 divided by 9.8. And so we would get our time is 9.97 seconds. But then we have to remember that that's only the time to my max height, because I had to make my final velocity 0 at the max height, and again, that's only halfway. So in order to figure out the total time, the time up and the time down, I have to multiply that by 2. So I times that by 2, so we get our total time of 3.94 seconds. Do you have any questions on that first part, Anna? Or the 6 other people watching? Alright, then once we have time, remember that's the one variable that we can now bring over to my horizontal side. So we could just move that one right over. I have my 3 variables in the horizontal, and I know the total time the ball was in the air, so now I can solve for how far it went. So you just use distance equals VIT plus 1/2 AT squared. Plug everything in, and you should get that your distance is just equal to 22.98 times 3.94. So you get a total distance of 'that the ball went horizontally of 90.5 meters. Any questions on that part, Anna? Or, ooh, losing people, yes. Or the 5 other people watching. Alright, I mean, then what other type of example problem do you want to do? Any? Can we go over the stuff that was on the last lap? Yes. So there's only 2 questions on it. The most important part is that you need to know if you have 2 objects, and we're talking about how is it going to be phrased? It's going to be phrased as the gravitational force. So whenever you're asked about the gravitational force, again, it's not the acceleration due to gravity, it's the gravitational force between 2 objects. What we need to remember is Newton's third law, so that if you have your one object pulling at 600 newtons, this one object will also be pulling at 600 newtons. So you need to remember they're equal but opposite. So it doesn't matter what we do to this one to increase the force of this one is also going to remain the same that we increased. So like, if one increases, the other one's going to increase. So they're going to stay the same, equal. So that's the first piece of information you need to remember. And then the second thing is knowing this formula. There's one problem where you legitimately just have to plug and chug. So you're going to be given the radius, you're going to be given the masses of the 2 spheres, the 2 objects, and you just have to know how to use this formula. So you're going to be solving for your gravitational force. We know that big G is 6.67 times 10 to the negative 11. You're given both masses, and you're given the radius. So you legitimately just have to plug everything into this formula. Does that all make sense? Here, I'll leave that up there. Parentheses. I mean, basically, you have this whole top and then this whole bottom. Like if you were plugging it into your calculator. And I would honestly, like, put all of G in a parentheses and then everything else, like, in a big parenthesis. This one, if people get it wrong, is just because we're plugging it into our calculators the wrong way. So just make sure you have the parentheses where you need them. Oh, the negative 11 doesn't have to be in parentheses, no. It's just, I mean, that's how you would type it in to your calculator. I would type it in with parentheses around it, just exactly like that. Atlas, go to sleep. Stop staring at me. Go to sleep, little man. You're so tired. Alright. Any other questions, Anna? Or the other people watching? 3? 3 other people watching? I wonder if I'm watching somewhere. No wonder someone's squirting. He won't lay on the couch unless I'm laying on the couch. He legit won't sit there. He's sitting on the floor next to the heater. Oh, now he's stretching. Where's he gonna go? Or he'll come sit right on my lap. He won't sit on the couch without me. He's going back to the kitchen. I'm too much of a distraction. Any other questions? Or I'm gonna leave. So speak now, Anna, if you have any other questions. Feel free. We'll be there from 7 to... I'll probably leave around lunchtime. Probably noon, 12:30ish. But feel free to stop by and see him. He's becoming such a big little man. Are those all your questions, Anna? Can I leave? You don't know? You're I wonder who the other person watching is, because I don't think I'm watching. You don't feel ready. Did you do the review sheet? Finally? I think if you do the review sheet and you got everything right on the review sheet, I would say you're ready. I'd also go over old exams if you have them. I mean, a lot of the multiple choice questions I tried to make pretty simple. I mean, some of them you have to use kinematic equations, knowing your free fall, and projectile information. I think we're all pretty decent with force. I would think you're ready. Questions? No? I'll wait till 2:57. How don't you have one? It's posted on Schoology. You could just have the problem up, do it on paper, and then check your answer later. Come on, little man. Come lay down. Come here. Come here, you. What did we do in the beginning of the year? Beginning of the year, we did vectors and scalars. So you have to know the difference. Oh, the exams. So you'll have to know the difference between a vector quantity and a scalar quantity. You'll have to know, if I walk 3 meters this way, 2 meters that way, and 3 meters that way, what's my total displacement? Speed equals distance divided by time. We did that in the beginning of the year. And that's pretty much it. And the kinematic equation. 1 more minute to ask me a question. What? What you do? Average speed is the total distance divided by the total time. I'll wait till 38 since you keep asking me questions. I just said total speed is, your average speed is your total distance divided by your total time. Any other questions? Total distance divided by total time. Any other questions? If not, okay, sounds good. I'll wait for your email. Peace out.